I barely finished the last machine and I started building another one. This one's a little bit different. I'm using ball screws. These are 1204 SFU. One here, and there's two on either side. There's a shorter piece for the Z-axis. I'm still using the MGN 12 linear rails, but this time along the Y-axis I have a single one on either side. You can just about see that one there. The plate's about 5mm thick, actually a bit 4 to 5mm thick. And what I wanted to do when I started designing this machine was to really pare it down from the previous one, that one over there, and to reduce the number of parts and the overall thickness of the aluminium profile. You can see here the Z-axis uses a single 20 by 20 piece of aluminium profile on either side. All the aluminium profile for this machine is the leftover parts from the X-carve, which has been sitting around in my studio for a number of years now. I've cut the plates myself on that machine there. I didn't bother filming anything, but there's plenty of pictures. I'm using an 80mm water-cooled spindle at the moment, although I'm not really a fan of water-cooled spindles. And I've designed some mounting holes on the back plate so that I can use one of these open build router spindle holders. It's about 70mm if I remember correctly. Simply bracing the pieces and actually spacing the rails a bit further apart has meant that this machine is already a lot more rigid than the one I designed using the C-beam, and cost-wise it would work out a lot cheaper. I simply push fit the bearings into the M plates and the SFU ball screw just sits in place. If they're a little bit loose, I can put some shim washers that can come in sizes from 0.1 of a mil to tighten that up. I've designed the machine in such a way that the ball screw is on the inside of the plate along with the linear rail, and the reason I've done that is so that I can minimize the amount of, or eliminate in fact, the amount of surfacing I need to do, or what you would otherwise do to machine plates, which dramatically increase the cost of parts. So in theory I only need to surface one side of this plate, and in this case I didn't surface anything. I'm also working on a new touch probe using a nice metal momentary snap to action button, and I've also got a pilot light here. This is a 4 terminal, 2 are normally open, 2 are normally closed, and the light will connect as normally open so that when it's pressed it turns on, and the normally closed goes back to the probe terminal on the controller I'll be using, and when the signal is broken that is read as a probe cycle being complete, and in particular G38.4 or 5 probe cycle. This is a bit of Velcro mat. I think this is very nice. Still not sure whether to fit it into the table or to try and offset it, but my spindle doesn't overhang that far, so I'm not sure if this is even going to reach. It may have to be this way. Using some melamine here for the sub wasteboard, which is a little different from most CNC machines, but essentially it's waterproof and it's nice and flat. I've got another version of the plates here in high pressure laminate. It's pretty good. I'm really impressed by this material. I think it's a good alternative to acetal and aluminium. Only thing is, I don't think this will take a thread that well, so anywhere where I'm mounting stuff I need to make sure that there's plenty of room to also put a bolt on, for example the stepper motors or the proximity sensors that I decided to use, which are different from the barrel types. These are more rectangular. Down here I've got some barrier blocks which I'm wiring up in anticipation of a method I'll be using to connect everything up to the controller, which I'll be doing through relay modules. These are opto-isolated relay modules, and what it allows me to do is to use 24 volt DC power to the limit switches and buttons and so on, the e-stops, and then create a logical connection to the terminals on the controller. This is a Gradus M1 Pro, which I've decided to go with. There's not much information about this board. The one thing I will say is, while I was flashing the controller, I noticed that I had a compile error. The chip on this uses the same as the Arduino Uno, but the bootloader is different. It uses the bootloader for the Pro or Pro Mini, which takes up more space. So I had to flash that or burn the bootloader to an Uno, and I had to use these ICSP cables here and a USB bootloader to do that. So if you do buy this controller, you will need to get yourself one of these as well, and that's not in the instructions. I'm planning to have this machine inside an enclosure, and for the parking and door enclosure features to be activated on the firmware, so a little bit more security to operating this machine. And my thinking actually is that this is something that, once completed, will meet some of the criteria to then be able to find itself in an educational setting and used in as an educational tool. I think what I'll do is I'll talk more about that when I've got the rest of my components for the controller and I can actually demonstrate how that works. Okay, the last thing I've done is wire all the stepper motors and the limit switches, and this is what this coil is here, or collection of wires coiled. The wires for the stepper motor are 4-core, and the wires for the proximity limit switches are 3-core. So there's not much more for me to say at this point in the build. I'm sure lots of people have opinions about how I've set this up, but I wanted the machine to be very utilitarian and for it to be very visible how it works. In the next video I'll look at how I assembled a new controller box and talk about some of the decisions I made along the way, so stay tuned for more chin scratching.